we have seen how structures are represented. We have also learnt about pointers. So, today we will be looking at the structures once again in a different light. As you can see here, a structure can be declared as is shown here, a student structure, struct stud is consisting of 3 members or 3 fields. So, they are the role, the department code which is a character array, and CGPA which is a floating point number, and A, B, C are 3 variables of the type STUD, stud. The individual structure elements you know can be accessed by A dot role. So, A is this field, or B dot role, C dot CGPA. So, with this dot operator we can access them. This was known to us, right. Now, we can also, we have seen that we can define an array of structures where class is an array of students, class size is 100, and each element is a structure of type stud. The structure elements of the individual records can be accessed with this dot operator, like class I, any particular element of that, say for example, here any particular element I take, and so this is class I, where I is this index. I come over here and get a particular field of this. So, this has got a number of fields. So, I am coming to the role field or the department code field or the CGPA field. This was also known to us. Okay. So, here we are trying to apply that through an example, sorting by roll numbers. So, here we have got a set of students. Look at the declaration here. Student struct stud is the structure having role, department code and CGPA. Now, in the main function, what are we doing? We are defining struct student class 100. Now, struct stud has been declared. It has been declared globally even before main, that is possible. Okay. And here I am saying that class 100 is one array and T, and there are some integers. T is again a structure. T is also a structure of type stud. Now, I am reading the number of students. Okay. How many students are there in the class? The array can accommodate at most 100, but I am reading the value n. Now, for each of the elements, look at this, this is our familiar for loop here. For k is equal k 0 to less n, I am scanning the class, the roll number of that particular student, the department code and the CGPA. So, in that way I read, here I am reading the array, all right. The array is being read here, array is read at this point, right. Now, what I am doing now, next let us look at this loop. What are you doing here? For some value of j, if the role of that student, so here I have got my array, I am coming to any particular j, a particular element, and looking at the roll number field of that, if that is greater than some other value k, if is greater than the roll value of k, then I am exchanging them, just as we sort. Now, what are we sorting here? In the example earlier that we had done, we are sorting integers or sorting real numbers. Here what we are doing, we are sorting the entire structure. As you can see here, the entire structure, the j is coming to t. So, t is again a structure, k is coming to j, and so this is a swap operation, swapping structures, swapping the structures. all right, and this I am doing for k is the internal variable and j is the external variable. So, my diagram should be a little different. The diagram should be so for every j I am looking at one j and I am varying k from here, this is k is varying from this point to this point to the end of the structure and comparing with this j value. If this is any element that is less, that is coming over here and it is being swapped. So, you have seen this swap algorithm earlier. So, that is being swapped here and then I update j and I go on doing this. So, this is how I can apply the sorting algorithm that we had learned, that can be applied for sorting student records. All right. Next, the other thing that we have to look at is pointers and structures, how they can be intermingled. You may recall that the name of an array stands for the 0th element of the array. So, if this be an array, then if the name of the array is A, then the name A and A0 are synonymous, and so A is also, A can be considered to be a pointer that is pointing to A0. All right. Now, consider the declaration this. This is also true for the names of arrays of structures. So, if I have a declaration like this, you look at the declaration yourself. So, you can see student is a structure and I have declared of the type student an array class 100 and star PTR. Now, what is star PTR? What does it mean? You know by now. Just as we had done this, keep it side by side, in star p. What does it mean? It means that p is a pointer that points to integer data type. Here it means that PTR is a pointer that points to stud type of structures. This type, only to this type of structure, PTR points to that. So, now what do I have? I have got an array called class, each element of which is of type student structure, and I have got a pointer PTR which can point to such structures. Okay, it can point to such structures, any of these. I have not yet initialized this. Okay. The name class therefore represents the address of the 0th element of the structure array. So, if we go back, so if I have this, then this class means it is a pointer that is pointing to this element class 0. All right, just like an array. So, and PTR is a pointer to the data objects of type struct that we have seen. The assignment class assigned to PTR, what will it make? It will make PTR now to point to the first element of the array. Here is class and PTR is now pointing, when I do this assignment, note that they are of the same type. So, when I do this assignment, this is pointing to this element. All right. So, it will assign PTR to class 0. Understood? When the pointer PTR is incremented by 1, that is PTR plus plus, you should be able to tell me what will happen. The PTR will be incremented to the next element of the array. So, the actual increment will be by a scale factor. And what is that scale factor? That scale factor is size of stud, size of this structure stud. And you know that it has got a roll number, it has got CGPA. So, depending on the different data types that are housed inside that structure, it will vary. So, the value of PTR will point to the next element will be incremented by size of stud. Fine, this much is clear. So, it is made to point to the next record. Once PTR points to a structure variable, now this is something new, the pointers can be accessed as PTR roll, that is possible. So, let us see what is happening. You are being introduced to this operator, the arrow operator. So, here or this only comes if the left side of this operator is a pointer. So, it is if suppose I have got some structure and pointer P or PTR is pointing to this structure and it has got different fields, say CGPA is a field. If I write PTR arrow CGPA, that means that I am now pointing to this, I am actually accessing this element of the structure. Just as suppose this structure is class and this element is class 1, say. I could have written class 1 dot CGPA, and here what I have done is I have already done this that PTR, the pointer PTR was assigned to class 0 and then I did PTR plus plus. That means, now where is PTR pointing to? Is PTR is pointing to class 1. So, I can also do PTR, now PTR arrow CGPA. These two are equivalent, this and this are equivalent. Okay. So, here also you can understand this. So, let us move ahead. Similarly, I can go to another field by PTR slash department code. I can go PTR CGPA, PTR roll. The symbol this symbol is naturally called the arrow operator. Okay. Example, you can read this type def. Now, here I am defining a type, the name of the type is complex. And what is this type complex? It is a structure with real and imaginary parts. This is what we saw earlier, right. Next, I have got a function print complex star A. What does it mean? A is a pointer to type complex. So, printf whatever, there are two placeholders, A real, A imaginary. So, why is it possible? A is a pointer. So, it is pointing to some complex number, it is pointing to some complex number whatever that is. A is a pointer pointing to that, and I am going to the real part, I am printing A real, and this part is A imaginary. Okay. So, this is what is being done by this piece of function code. So, now swap reference. I have got complex A and complex B. That is not, I am sorry, it is not being visible here. There are two A and B, there are two pointers in complex. So, there is TMP, I take another structure of named TMP of type complex, and I swap the pointers here. That's what you can work it out. That means that A was pointing to some structure, and that A is pointing to this structure, and this particular structure is copied to another structure temp, and B, then B was pointing to another structure. B and A are swapped. So, now B is pointing to this and A is pointing to this. Next, I am making B to point to this. So, that is how a swap operation can be done and how we passed on the parameter to this. So, the main program can define complex x 10 and 3, y is minus 20 minus 10, because of the resolution it is not visible. So, print x and y, then swap reference print x and y. Now, can you guess and tell me whether the swapping will work in this case or not? The answer is yes, it will work, because it is a call by reference. So, here whatever I am swapping here, that will be reflected in the main program also. Okay. So, here is an example. So, let us move ahead. Now, one warning is there that when using a structure pointers, we should take care of the operator precedence, because here we have seen the star symbol as well as dot symbol, right. We have seen the star symbol as well as the dot symbol. Now, this dot has a higher precedence than star. What does it mean? It means that if I have got something like PTR role, then and star PTR dot role, what will happen? This dot has got a higher precedence. So, these two are the same thing. PTR role, PTR is a pointer and the role is that particular field, and star PTR is what? Star PTR is that particular structure, and I am going to the role field of that structure. So, star PTR dot role, that is these two are equivalent, but if I had done this, that would be an error. Why? That would be an error because this dot operator has got higher precedence than this star operator. So, basically I will try to get the role field from the pointer PTR, but that is not the case. I cannot get there is no role field inside the pointer PTR. The role field is there in the content of the pointer PTR, that is star PTR. So, I must make first star PTR within bracket, then dot role. So, this is correct to mean this, but this is wrong. The operator arrow enjoys the highest priority among operators, among all these operators, it has got the highest priority. So, we have learnt, so here in this case what will happen? Plus plus PTR arrow role. As we have said that this has got the highest priority, we will go to where the PTR is and go to the role field of that, and after that we will increment this plus plus, although it is shown as a pre-increment. So, that will not have higher precedence than the arrow operator. So, if I want to first increment the PTR and then get the role, then I should do plus plus PTR arrow role will do the intended thing. This will not do the intended thing. I hope this is clear, this part. Now, structures and functions. Structures can be passed as argument to a function, and a function that we have already seen, a function can also return a structure. So, We have seen that using two complex numbers how we can do that. So, here again we look at that example that we have got a complex number, complex structure with two fields. I have now changed the names float RE and float IM, and in the main function I am scanning and A dot RE, real part of A, real imaginary part of A, then real part of B, then imaginary part of B, and then I call the function add AB. What is happening here when I call this add AB? What am I passing? A, B and here x, y. So, it is a call by value, right. So, here this is copied. Now, struct complex x, y, there is no problem here, it is not like swap, I just want to add. So, I have got two internal variables x and y, and T, that new structure T is taking x's real part and y's real part, then it's I am getting the real part of T, and in the imaginary part of T there is nothing here, there is an excess space. In the imaginary part of T I take the imaginary part of x and the imaginary part of y, then I am returning this T to C, where C is also of type complex. Since the types are matching, I can pass it on over there. Now, this is one way of adding the complex numbers. Now, if this is clear, now let us look at an alternative way of using the pointers. Here I just change this, other things are same. What I am doing here is I have called them, now passing the address, now I am passing the pointers. In the earlier case I was passing the value here, and now I am passing the pointers. I am passing address of A, address of B and address of C. Now, inside this add function what am I doing? I am taking x and y. So, these are pointers, I am taking them, and T is real. So, T is a type pointer. So, So, T is a pointer that is pointing to another structure of the type complex, and T's RE, T arrow RE means the real field of this T will be taking the real part of x and real part of y. So, here x plus y, the sum will come, the real part of x and real part of y will come here, and here the imaginary part, here the imaginary part of x and y will be added. Okay. Now, when here I am not returning any T, because this T is nothing but this C. So, this T and C are mapped, it is a call by reference. So, C is also actually pointing over here. So, I get the result here. So, this is another way in which in structures we can use pointers also. So, these are relatively more advanced aspects, and you will gradually practice this and you will get familiar. Thank you.